So for mild hybrid, as you can see, here is the mild hybrid. Mild hybrid is equipped with a small electric motors. You can compare to the full hybrid. Uh, so the mild hybrid is you can understand a gentle hybrid, or you only can use a middle hybrid. Most they are rely on the ICEs. The cars energy rely on the ICEs. Uh, so the electric motors on the mild hybrid is only doing for helping maybe the car start it, helping the car start it. Uh, for example, at the traffic light, when you when you open the engine, need to start up the cars. So the mild hybrid is the very gentle hybrid,
Just to
equipped with a very small electric motors. So this is the mild hybrid. So you can see the battery is smaller, right, compared to the full hybrid. Full hybrid still have a larger, a little larger batteries. So as I recall, what is this? What's the green one? The green.
so that's the DC to DC. Actually, OBC. Yeah,
Okay.
the OBC.
Don't worry, we'll have a little bit recall for
Exactly. So I'm trying to.
Okay, no problem. We'll have a recall.
That's it. Okay, no, it's not the onboard charger. It's a DC to DC
Yeah,
converter.
it's a inverter. Inverter.
Oh, the
Yeah.
green is the inverter.
Yeah, when you miss what it things, you can find the green cable, right?
The three cables
The
going to
orange,
the
the orange cable. There's three cable, right? Three orange cable to the
drive.
to the motors, right? And there is two cables in, three cables out. So helps you to understand what's exactly the thing is. So the inverter is for transform the high voltage electricity to three-phase voltage.
Yes.
So this helps you understand. You don't have to hard memorize what it is.
Okay.
You should understand
Just having graphs of
what
it.
is the function of it by recognize the cables, the red cables.
Okay, so for like a recap, the DC to DC converter converts the high voltage from the big battery to 12 volts.
Yeah, to 12 batteries.
So, yeah. So basically, that's what it does. And then on the reverse side, it could help to initiate starting for. You send the message to the BMS in case you want to start afresh. So okay, I'll get that part right. So if probably you need to send signals to if the traction battery will not pick by itself, this low voltage battery will also send signals to the BMS of the traction battery.
Yes.
Those are basically the work that it does. So the interpreter, the transition is on that DC-DC controller. While the onboard charger is the internal charger. The OBC. Yes.
OBC.
Yes.
Yeah, OBC.
So the internal charger. Then the separation between the ICE.
For you to understand, the traction battery. Let's see on the batteries. So this is the real HV battery, right? This is the real HV battery. If we have this is the high HV also have a low is low LV low voltage part. So then I think this is the low voltage part. So the 12V battery still have something like going to the here to the average one. Because BMS is inside. The BMS system needs to 12V voltage to activate.
Okay.
Activate.
Yes.
Uh-huh.
So that's the part I was trying to say.
Yeah. Yeah. Uh-huh.
For needed activation.
Yeah.
Okay.
Uh-huh. Okay.
Which is an important part of the low voltage battery.
Yes.
And
yes.
it does that through the DC-DC converter.
Yeah. Uh-huh. Okay. So the inverter is for
Conversion of DC to the three-phase for the motors to drive.
motors. Yeah.
All motors are three-phase.
Yes. All the AC motors are on three phase in EVs. In EVs. In EVs. So 90%, I think it's 99% maybe. The motors using on the EVs are using three phase AC motors. AC motors. So it's very, very little motors using the DC motor. Most of them are using DC motor, using AC motors. Mhm. So we're clear here?
Yes. So back to that. Right. The refresher was necessary.
Yeah. Okay. And so the mild hybrid is equipped with a very small.
Again, the small motor is also three-phase in this diagram.
Yes. Three phases. Three phases. And the full electric, full hybrid, usually equipped with a little larger motors. And the electric motors are capable to driving the vehicle at low speed. At low speed. So you can see the clutch coupling here, right? Clutch coupling. So
Yes.
do you find the difference? The clutch coupling is
Yes.
beside the
Yes.
here is beside the ICE and
The motors.
and here is
After the motors.
After the motors. So in this case, the mild hybrid, the motor cannot directly driving the wheels. Only can helping the engine maybe at start. But for full hybrid case, you can directly driving the wheels, only at low speed. At low speed.
So in this case, the battery system does very little work.
Yes.
So it's still the ICE that does the major part of the work.
Correct.
But in this place, in this full hybrid, they can work separately.
Yes.
At that point where the what do you call it now? The shaft? Is this not the shaft? That stuff in between.
Coupling. Yes.
The crankshaft. No.
The-
What's it? this part.
You mean
Yeah,
this?
this
The
is
clutch, yeah, upper.
So apparently this one can actually isolate for everything here to move the car.
Yeah.
But as also this one can also isolate for this ICE system with this battery
Yeah,
to move the car.
that's true.
So that's full electric.
Yeah. No, it's a little bit hard to understand for the new lenders because when we introduced this, they still have the plug-in hybrid and electric vehicle with range extenders. The L1, the L9 is belong to this uh, electric with range extenders.
So on this mild, does it have an external charger? Maybe no.
Sorry?
The mild,
My mild.
does it have external charger?
No.
Oh,
No.
so now I understand.
Yeah.
So there are some other cars, for example, we have this Highlander
Yeah.
that is battery.
That's true.
Yeah, but then again, it just works like 20, 30 minutes.
Yeah.
Then it peaks on power and then for the whole day. So it's just for the initials.
Yeah.
But it does not have a charger.
No,
So that's where the category of the kind of electric vehicles we talked about yesterday.
Yeah.
We talked about the HEV.
Yeah.
We talked about the BEV. The HEV does not have a charger.
Yeah.
But the PHEV, the plug-in HEV has that's a
everything.
full hybrid system.
That's true. That's true.
Also, this is the HEV in a way. Okay, I get it.
So you can understand that HEV concluded the mild hybrid and full hybrid.
Yeah.
So the HEV, these all two belong to the HEVs. So HEV can divide it into mild hybrid, full hybrid. They are not they both don't have the OBCs.
Oh.
OBC onboard chargers. And for the other three, like the plug-in hybrid, PHEV, EV, and the EV with extenders, they both have OBCs, as I can see. They both have the OBC, onboard charger OBCs. And let's find the difference between these three. You find the difference between these three. The left is the PHEV, this is EV, and this is EV with range extenders.
Okay, so the range extenders does not have the clutch.
Yeah.
So it has two drives.
Two drives.
Yes. That's two motors, three-phase motors, but they are both powered from the inverter, the same inverter. So it is instead of the clutch, it is the drive with a smaller motor that drives the ICE. Why on the bigger motor working with a smaller motor works with the ICE system, a bigger motor works with the battery system.
Yeah. So for this case, the range extender, so the ICE work with this motor to combine with extenders. What we call extenders. So this motor is only for generating electricity. So this motor and this engine, they will not directly connected with the shaft.
I realized it.
So they cannot directly driving the wheels. The only function of this together is to generating electricity for the HV batteries. You understand?
Because now, if the IC is working, okay, that
Mhm.
means the IC is working for the front wheel only. Because now, what is the internal combustion engine? Apparently, the power.
Mhm. So, you know, for traditional gasoline cars, you have the ICE engine, ICE, and also you have a kind of generator, small generator
Yes,
to charging the 12V batteries, auxiliary
that's
batteries.
the alternator in the case. In this case,
Yeah,
an
in this
alternator.
case, you just change this to change the these big motors and the big generators to generating larger electricities
Yes.
for the HV batteries.
Oh, so it's okay. That's what the extender is. Okay, now I
That
get it.
yeah, exactly yeah.
That's why. So it
Uh-huh.
extends the life of, even though the battery is already charged
Uh-huh.
and the battery is working.
Yeah.
So, but there's another three-phase generator, alternator.
Mm-hmm.
Simply said alternator, but is a generator that is not taking power from the inverter, but is supplying power to the inverter to the battery.
Yes. So
So it is one way.
yes. So it's one way to
Good, good.
here.
So then the ICE is also a drive.
Sorry?
I'm asking,
Uh-huh.
this IC, the internal combustion engine, is a front wheel drive, right?
Front wheel drive, yes.
Because it's also driving the car while generating power.
Mm-hmm.
Oh, so I get it.
It can be uh, it can be real drive or front engine real drive.
Depending on where the engine is.
Depending on where the motor is.
Oh, yeah.
Because the engine didn't drive the wheels. The
So,
motor drive the wheels.
of course.
So here maybe just show one motors, but maybe in the L9 there's two motors. One motor in the front, one motor
At the back,
at the back. Or even
clearly.
three, one motor in front, two motor in the back. Uh-huh.
That's
So
for the extenders.
yeah, so that no, the extender is means the engine and the motor combined
It's
as
a
a extender.
separate entity, but it also generates power
Generating
to
powers.
the existing
Yes,
BEV system
yes. Generating powers to the HV for the
system.
batteries, HV batteries. Mhm. So, sorry for that. So the engine flow, I want to maybe the engine flow, the energy flow, when the extender running, there is power, electricity power, right? To go to here, right?
It's one way.
One way, one way. Uh-huh. And then if right now the the car is running, then the motor needs power, right? Then the if the HV battery is full of power, they will give electricity to here and then to the motor, right? And the engine, the extender also will, the power will goes to here.
So at the inverter,
Mm-hmm.
it is a pool. It's saying two sources of power.
Yeah.
If it needs, like, say, 1 kilowatts per hour to drive, for example, then from the small drive that's attached to the ICE, let's say about 400 kilowatts is coming from there, then it only requires 600 kilowatts from the battery, from the traction battery. So that way it is taking just a fraction and supplementing with power that's coming from the ICE. The extended life will be the result, the extended time, because now there are two sources of power.
Yeah, and if the motor didn't require, if the motor didn't require that more energy, then the electricity from the power from the extender will go back to the HV battery for
To
storage.
Because the inverter can handle both ways, yes.
Yes.
The inverter is built to handle
Yes.
back and forth.
Yes. That's true.
Very clear.
Right there. Okay. And for this other condition. Okay. So for other two cases, can you say for EV and plug-in hybrid, or even plug-in hybrid?
Okay, but this plug-in hybrid does not have ICE power. I don't know why. That's this middle one, right? This one. Okay, so this is more like a complete EV system.
Complete big battery EV, pure electric.
Yes.
Yeah.
So no ICE conversion in the system. Internal charger, inverter, drive, cost, traction, batteries.
Yeah.
So this is more like a simplified 100% EV system.
So for EV, let's draw the energy flux. So the motor can be a generator, also be a motor. So when the car is moving accelerations, the motor needs power, right? Now the HV battery will give the electricity to the inverter, right? Inverter transform it to AC
To AC three-phase and
to three phase to the motor. So this is the first and the first cases. The second case is when the braking in the braking case. So the car is slowing down. Right now, the motor will be a generator, energy recoveries. So in this case, it will be a generator, generating electricity back to the motor.
only during braking.
Yeah.
What happens when you engage in neutral? Does it require power?
Sorry.
If, for example, I was on the high speed, say about 120, and I'm in a slope. In a slope. Descending. So I just want the car to move free fall. If I engage neutral on the gearbox, I mean drive is for D, reverse is arrow, N is neutral. It's make it flow free.
Well, for EV, you separate using the neutral gears. You still put it on B mode or D mode. Let's show on the airline. Okay, let me show you on the airline. Did I have to? Did you put the key here? Oh, it's here. Okay.
Somewhere here. For the other guy,
Oh,
okay, that's
that's
it.
it. Okay. maybe you can.
Yes.
So yeah, neutral, right? Park. Maybe you can help you to. 理想同学，
主驾你好，
将副驾驶的座椅往后退，往下放。
为了安全起见，你需要手动操作座椅侧方的
Maybe
开关
you can-
来进行调节哦
Do。you feel tight? And maybe you can
Okay.
adjust your seat. Okay.
Okay, I can see.
Yeah. So park. Yeah. Park. Reverse. Neutral. D mode. And here is the. Let me see. Well, this is a little bit different compared to the Volkswagen ID4. So. Oh, they are charging right now. So they are charging right now. So right now we can put in the gears.
Okay.
Put in gears. So when when you put D mode,
It's to drive.
it's to drive. But if you put on a B mode, this don't have a B mode, but in Volkswagen ID4 they have a B mode. What is means B mode? B mode means it activates the energy recoveries. So when you are accelerations or in the snow case, you just leave the acceleration pedals and maybe
Use the brake to
use the
navigate.
brake. And right now, even you don't press the brake pedals, it will slow down the speed because the motor will doing the energy recovery process. So the speed will slow down, and then the energy will generating from the motor to the inverter and then to the HV batteries.
Yes.
So
Because now, as the car is still moving, the drive works both as a motor, contraction motor, at the same time a generator. So if it's not taking power but it's still running, it is generating power.
yeah, clear. I can understand.
Okay,
Okay.
I get that.
Okay. Let's go on. Yeah. Can I open? Oh.
I think it's locked from here.
Let me see if they not. 请先拔出充电器。Let me see.
I think it's from the Kia. No.
Let me help outside.
Okay. Oh. So that's like a child lock of some type.
So for EV is more easy to understand because it doesn't have IC. So the motor can activate its motor and also the generators, electricity generators, storage the electricity into the HV batteries.
So in the case of this, this is a PHEV,
This is the PHEV and also
an extender.
extended with the extended. A PHEV is extended.
More than one motor.
Yeah, more than one motors.
So in the case of these two, there's also a point, whatever happens here in terms of recovery, energy recovery. It can also happen here too. Same Sorry.
Yes,
Same principle.
yes, same principle, but the difference is in these cases, the PHEV, they have a transmission systems and transmission gearbox systems to directly drive the wheels.
Yes.
You see the coupling right here?
Yes.
It's for the engine to directly driving the wheel forward. But in extenders, you cannot directly drive the wheel with the ICs. The IC, the only function for IC is to generating rolling the motors to generating the powers for the motor or for the HV batteries. But in this case, the engine can directly drive the wheels. So this is first. And second, the clutch is lift off. Then the motor can drive in the wheel. Separately.
At the point where the ICE is the one driving the shaft, the wheels,
Yeah.
what happens to this motor? Is it also turning the same speed with? But
No.
is isolated.
Yeah, that's the clutch coupling functions.
Okay, so it does not generate power recovery power back to the battery.
Yeah. So for there's only two. We have say one case is the motor shut off. Only the ICE drive the wheels, and the second is the ICE shut off. Only the motor drive the wheels.
One at a time, yeah.
The third is they both work. They both work. Drive the wheels.
They take just small fraction from here, a little lesser fuel, lesser battery,
Yeah.
working together.
Working together, power together to driving the wheels.
Hmm.
Because the life flow.
Okay.
So can you
Yes.
understand? Can you
Yeah.
understand clear about,
Yeah.
about all these situations? A little bit complicated. I mean,
Yeah,
for
but at
people
least-
who didn't have this before, because in in EV modes, in EV new EVs, they have different driving electric driving types. They're all NEVs, but sometimes they have
Different drive
different
types.
drive types.
Okay.
So from this, you can see if a car with a PHEV, with a PHEVs, they are more complicated because you have the engine, also have the transmission box, also have the clutch coupling, right, and motors, and all the
Like this one,
no, this one is a
extender.
extender with extenders, so it's less. You don't have the transmission, right? You doesn't have a transmission.
Oh, really?
Yeah, don't have it don't need a transmission.
Oh, that's true.
Because you don't need to drive the wheel directly. So this don't
That
have
engine is just a generator,
yes.
but it uses fuel.
Yes. So so that That's the reason we call it extenders.
Okay, now I understand it. I just got it now.
Extenders.
Extenders. Oh, I
This
see.
is called extenders.
Okay, now I get
So
it.
the only function for this extenders
Is
is
to
generating
generate power.
generating power to motor or to HV.
So the engine is just a generator.
That's true. No need for transmissions. So for EV with extenders, it's less components compared to PHEVs. But the EV is the one with most simplified structures because no
The 100% EVs.
100% EV.
No
100%
engines.
No engines, no extenders, no other
Just simple.
motors. Just simple, just HV batteries, inverters, OBCs. No need to that things. Uh-huh. So less components means less maintenance,
And less work.
less work.
More components in the case of plug-in hybrid, more work.
That's true.
Because the 100% mechanical,
Yes,
100% electrical.
that's true. So there is advantage.
Okay, so I understand this already.
Yeah. So there is advantage and disadvantage for both.
Electric vehicle.
As you can see from pictures, the EV has the biggest, the largest batteries,
Yes.
right? The largest batteries compared to others, because that's the only resourcing energy sources for the PHEVs or with extenders. They are all can using the battery or using the energy, using the fuel to generating energy for the motor or drive the wheels.
Okay.
Okay.
Yeah.
Okay.
I wanted to explain this third part so I can understand.
Yeah. Okay. Okay. Then. Okay. Maybe for small questions. Uh, how can the range of to be extended in a vehicle that with a ICE? This is the traditional fuel vehicle. How can the range extended?
Yes. One way to extend the vehicle range
Is
by increasing the size of the battery. There's no. Okay, now this is the traditional
traditional,
ICE
yeah, ICE and vehicle,
by
fuel
increasing
vehicle.
the fuel tank. Huh? By increasing the vehicle power. Okay, but number two and number four.
Number 2, number 4.
Number two and number four, by fitting a larger fuel tank if it's possible, it will give you longer range. Then because now you have more fuel to take more mileage. Improving the vehicle efficiency, there are several other things you can do. Whatever it is that you can do to increase efficiency, it will
Yeah.
increase speed. It will increase
That's
yeah.
right. That's
That's
right.
two and four.
Yeah, the number 2 and 4.
Yes.
Okay. And how can a hybrid vehicles range to be extended? A hybrid vehicles. Hybrid vehicles.
Okay, by increasing the vehicle power, no, it does not increase. Improving the vehicle efficiency, yes. Increasing the size of battery, yes. Fitting a larger fuel tank, yes. 2, 3, and 4.
Yeah, that's correct. Okay. How can an electric vehicle's range be extended? Electric vehicle, pure electric vehicle, battery electric vehicle.
Increase the battery power, no. Fitting larger tank, there is no tank. This one does not have tank. Increasing the size of battery, yes. Improving the vehicle efficiency. So it's 3 and 4.
It's really full. Okay, correct. And okay, sorry. What can be said regarding a battery's full electric vehicle?
It's always larger than the hybrid because
Yeah, the battery is always larger compared to the hybrid, right? Because hybrid
yes.
compared to full electric, sometimes smaller size. So this is
Yeah, because the full electric depends solely on the battery.
that's true.
The battery has to be larger.
That's true. So, for example, my Volkswagen ID4 is equipped with the 84 kilowatts
Yes.
batteries. And for this the Auto L9, maybe 30 to 40 something like that. 30 to 40 kilowatts. So it's much smaller, because it have like extenders.
But the range is higher here.
Yeah, yeah,
Now I get it.
yeah. But the combination range is high. But if only using the electricity, not generating, not running the engine stops, only using the batteries, it only have maybe 150 or
200 miles.
150 kilometers on EV mode. So can you understand? So if this car only rely on its HV batteries it only have maybe 150 kilometers range.
Because the battery is small, 40 kilowatts. Small.
Yes,
And the car is big.
Yes,
So it has it's carrying a bigger weight but with a smaller
that's true.
capacity.
So
The extenders, like you said, uses fuel. There's a fuel tank.
yeah, but the fuel price is much expensive. The fuel price is much expensive. So there is a very funny things that a lot of the driver of the Li Auto customers, they never or several go to the gas stations. they go to the charging stations because the charging price is much more
Cheaper.
cheaper. So they only goes to the gas station when they are doing a
Long journey.
a long trips.
That's another challenge.
So they have to frequently go to the
The charging station too.
Only if they have a charging pipe, a personal charging pipe on his apartment or house.
Or in the office or
Then
something.
they have to often go to the charge station because if they only rely on the HV batteries, they only can go 150 kilometers. So you have to it's balanced, you know. So
Okay.
you have to think about
The options.
the options. So that's the reason I goes to pure electric because for most maybe 90% of my cases I drive inside
the
the city,
town, yeah.
in the town from home to my office. So it's enough for me to drive on maybe 400 for charge one time or 400 kilometers or 500 meters. Uh, so it's
And
enough.
that's like a whole week if you're not
Yeah.
going to move to probably
Yes.
2 weeks if you're not doing too much of work.
That's true.
So another thing for this, all Li Auto are not built to be extenders.
The SUVs, they are risk extenders. The MPV they have selling right now is pure electric or BEVs.
Because to be honest, it may be like a bit of, and the price is really expensive. So if I have to go through all that stress, it has to be worth it. So if you ask me in terms of the value chain, I would want to say no to the extended, the ones with extenders. I'll probably want to say yes to the pure EVs
The pure EV, yeah.
because they save me a lot of stress.
Yeah.
I don't have to buy gas because the cost of gas usually it's a heavy thing. But then again, if you're going to a longer distance, you do long distance. Let's say you are you are into say you're into transportation, say like an MPV for example,
Yeah.
and you do long range transport. Yes, you should do hybrid.
Yeah.
You should do hybrid because you just charge your car,
Yeah.
and then you get to the first station, fill your tank.
Yeah, because
you're
for
relaxed.
right now, charging is still time consuming compared to fueling on gas. Because because the charging time is highly depending on the charging stations, the charging powers.
If it is not DC, it will take longer.
Yeah, if it's not DC and it's not huge power DCs, like maybe 20 or 200 or 300 or maybe 400 kilowatts charging pipe, then it will be slow down your charging time. Slow down your charging speed. So it's highly dependent because the gas station is rely on the gas from the tank from the gas station to the tank.
Yes.
It's already very fast.
Yes.
But for the electricity, it's different. It's rely on the facilities of the charging stations.
Okay.
Rely on the
The charging station.
charging station. Also rely on the platform of your cars because we have for example my ID4 they are using a 400 V voltage 400 voltage platforms. The whole electricity platform is a 400 Vs, so it only accept 400 V sticks. But many of right now's new cars,
750.
they 800,
I've seen a lot of 750.
750s.
Yes, like the Tesla.
Yeah,
The Tesla we used during the week before coming here was all 750 volts.
yeah, 7050 or maybe 800.
800, yes.
800 Vs.
That's
So
faster.
that's more faster. So it depends.
So another thing I want to ask, maybe I'm not asking too early. What's the safety measures for fast charging? Is it safe?
You mean safety for customers or
No. I mean for the car.
for cars?
Yeah.
Yeah, I think it's safety.
Yeah, because I understand
Mm-hmm.
from my knowledge of renewable energy,
Mm-hmm.
the wider the voltage. For example, when we're doing like a 2 megawatt system or a building, probably for this whole school, we need to use this hall, for example, and I need to put say maybe 12 megawatts. I can do this 12 megawatts. This is 40 feet. This is 40 feet. So I could do maybe 444, 12 megawatts. It can come into this place, put it AC tight, ensure that I will need to go as much as 1500 volts DC so that the amps that I'm driving will be reduced. What flows is current. The voltage does not flow. The voltage just creates a bandwidth for the current to follow. If the voltage is low voltage, if it is small, higher current will go through, systems will go bad because the cable will go hot. But when you open up the voltage and lesser current flows, the cables are very cold
Very good.
all through the years of the system. That we notice. So for higher systems, for HV, battery systems, we use higher voltage. For bigger structures, we don't have to worry. But if we use LV, all those small ones that we have around, it's okay, like this stuff. You just put 20, 48, 48 volts, 48 volts, 48 volts. After a while, all these cables start burning
Yeah.
because the current is high,
Yeah.
but the voltage is small.
Yeah.
So I think the high voltage creates safety
Yeah.
for the cars for charging.
Yeah. Okay, let's go to the next. Oh. What can be done in a hybrid vehicle to increase the power of the wheels? What can be done in a hybrid vehicle to increase the power at the wheel? What can be done?
Okay, so 1 and 2 works the same way because you can expect just certain amount from the ICE, maybe about the same amount from the DC system, electric motors. But when you combine the both of them, you can get extended time. You can increase power. So, what can be done in a hybrid vehicle to increase the power at the wheel? I will choose three.
3.
Because there's only an extent to which you can go from 1 and 2. They are the same thing. But when you bring the both together, you can get higher output.
Yes, that's correct. Okay. Oh.
Okay, you can take it back a bit. Let's read it properly.
Yeah.
You can take it back.
Okay.
Yes, let's read. At least we can analyze. What defines the maximum power of wheels in an electric vehicles? Internal combustion engine, electric motors. Because electric vehicles does not have electric motor, ICEs. The electric vehicles does not have ICEs. Anything ICE is not necessary.
Yeah, that's true.
So that's why it's electric motors.
That's true.
Yes. We will still analyze it. Let's still go back. We will still go back and then analyze it because that's
I
what's
will
my.
not use this. I will just use this.
Okay, what can be said regarding the electric motor in an electric vehicle? It has less power than the hybrid system. What can be said about regarding the electric motors in an electric vehicle? It has more power than the hybrid system. Okay, so from the last one, we know that the combined gives more power. So it has less power than the hybrid vehicles. Certainly, it has more power.
Electric motors. Electric motors. Yeah.
Yes. Okay, so let me be very honest. I've not really asked this question before. This is new to me. This part is kind of new to me. I might need to take a note. So it does it mean that the electric motor is more powerful than the ICE?
Yeah. So yeah, it's based motors. Yeah, motors because um,
So is there a rating for that?
a rating.
Um, okay, now the rating for power, energy power for drives is horsepower.
Mm-hmm.
So I probably want to ask in terms of horsepower
Mm-hmm.
between the electric motors
Mm-hmm.
and the ICE.
Yeah.
So which one has higher horsepower?
Well, electric motors.
Good. That's where, because this is my first time. You see, this is new to me.
Yeah.
If you gave me this one an exam, I probably wouldn't have the answer.
Yeah, electric
So
motors.
I think it's better to take note of this.
Yeah, electric motor.
So, but another thing I probably want to do is have an idea what the category is in terms of high power and in terms of the horsepower of electric motors as compared to ICEs.
Yeah.
I would like to have an idea of what the horsepower, different horsepower is. Yeah, so I can actually have like an idea for why I can say categorically that the horsepower. I know for one that the ICE has lesser RPM. You mentioned that yesterday.
Yeah.
That there are some motors, DC motors that have almost 20,000 RPM.
Yeah. 20,000.
That's
Even
crazy.
some can go to 30,000. 200 to 250,000.
That's crazy.
Yeah.
So, but the highest you get from maybe the ICEs is probably sometimes maybe 1,005,
Yeah.
depending on
Yeah.
2,000,
7,000, 8,000, 1,000. Yeah.
1,008. I think the highest I've heard about is
10,000.
2,005. So, which is far lesser. So, in my head, if I want to analyze, I'll probably say, okay, electric motors. But again, the electric motor is an AC motor.
Yeah.
And to get that RPM from an AC motor, I didn't see that coming. To get as much as higher RPM up to 20,000 or thereabout. So maybe that is maybe thought for another day, because really, I really want to have an idea. I want to understand. I probably want to take some lessons or read more on the electric motors.
Electric motor. Okay.
Why are they that powerful?
Okay. So.
And they don't go bad.
Okay. So maybe the lessons we deliver after we are give emphasize on the motors.
Okay. All right.
I think it's not because of this, because of the PowerPoint progress. What can be said regarding the category? Exactly, can be said characteristics.
The characteristics. What can be said about the categories characteristics? Different categories of electric drives. The characteristics are the same for every category. Oh no, it's not true.
Yeah.
Okay, this is the truth.
Yeah.
Characteristics differ from what, of course, they do. They differ. For example, this one.
Yeah.
The engine does not drive the wheel.
Yeah.
So it cannot be the same characteristic. They are different. Yeah.
True. Okay, I think. This is the last question. I think.
What I think.
I think the problem is the PowerPoint.
Okay, I think so. Yeah.
Yeah.
What are the categories of
Yeah,
the electric vehicles?
They're all for
Electric.
the most.
Okay, they are all the plug-in hybrid, mild, of course, full hybrid. It's important to understand it.
Yeah.
Yes.
Okay. Okay. This is the whole for them.
Okay.
Okay. Maybe take a break.
Okay.
We take a break. We
Oh yeah.
just rest on the break and.